figure shows part of the graph of y equals f of x, where x is a real number. The graph consists of two line segments that meet at the point 1a, where a is less than 0. One line meets the x-axis at 3, 0. The other line meets the x-axis at minus 1, 0. And the y-axis at 0, b, where b is less than 0. In separate diagrams, sketch the graph with the equation y equals f of x plus 1. So this plus 1 on the inside of the function affects the x coordinate, and we're going to do the opposite. So we're going to subtract 1 from the x coordinates, which is going to shift the whole graph 1 square in the negative x direction. So it's now going to intersect at minus 2 on the x-axis here, and positive 2 on the x-axis here, and the coordinate that was 1a is now going to be 0a. Therefore, the graph is going to look something like this. So that's my answer for part A. Part B, f of the modulus of x. The modulus is on the inside of the function. It affects the x coordinates only. So where x is positive, the modulus has no effect at all. So this part of the graph is going to be exactly the same. So that's going to stay exactly the same. It's going to go to the point 1a. It's going to cut through at 3 here, and this is going to be the point B. It's where x is negative that it matters. So x is negative over here. But what the modulus does is gets rid of that completely. Where x was previously negative, the modulus now makes that x positive, and so returns the exact same values we had when x was positive on the right-hand side of the y-axis. So we're now going to have the graph looking like this. And that's my answer for part B. Right, part C. Given that f of x is x, the modulus of x minus 1 minus 2, find the value of a and the value of b. So we're now told the actual equation for our graph. So this is the graph of y equals the modulus of x minus 1 minus 2. So let's look at this then. We need to figure out what a and b are. First thing, I know that when x is 1, y equals a. So if I substitute that coordinate into this function, so y is a when x is 1. I find that a is equal to the modulus of 1 minus 1, so 1 minus 1 is 0. The modulus of 0 is obviously 0, so a must be minus 2. Now let's pick another coordinate to substitute into this. Well, we want to know what b is, so let's substitute the coordinate 0. The x's coordinate is 0, the y coordinate is b. So b equals the modulus of 0 minus 1 minus 2. The modulus of 0 minus 1 is minus 1. The modulus of minus 1 is plus 1. So b is minus 1. So that's my answer for part C. And then finally, part D. We need to find the value of x for which f of x is equal to 5x. So let me draw 5x onto my graph so I can see where it intersects with the f of x function. 5x, I know it's got a y-intercept of 0, it's going to go through the origin, and it's got a gradient of 5. So the line I'm going to draw is going to be much steeper than this line that's got a gradient of 1. I know this line has got a gradient of 1 because I can look at the equation here. I've got a 1x. So I'm just going to draw a straight line that's got a gradient bigger than the line already shown. Which means that they're only going to intersect in one place, here. And crucially, that is where this part of the graph was affected by the modulus. This was the bit of the graph that gets flipped, that gets multiplied by -1. So I'm going to take my f of x function, this, and instead of the modulus, I'm going to write -1 times x minus 1. Then I've got the -2, and when does that equal 5x? Multiply this bracket out, so -x plus 1 minus 2 equals 5x. Add the x to the right hand side, and the 1 minus 2 is -1. So x is -1/6.